All right. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum and very good evening, everyone, and very good morning to our distinguished guests. It is my great privilege to serve as the host for this exciting webinar on self-assessment for learning in technology-rich environments. Today, we explore a topic that groundbreaking and pivotal in shaping the future of education in the digital age. Before we begin, actually, I want to acknowledge the ILT department, Instructional Learning Technologies department at SQU. Their unwavering support and commitment to fostering meaningful academic dialogues make events like this possible. I would especially like to thank the IoT Community Service Committee, especially Dr. Muhammad Eid, for organizing this wonderful opportunity for us all to come together and share knowledge.
Thank you, Dr.
It
Muhammad.
is
Thank you very much.
welcome. It is a tremendous honor to have Dr. Ahmad with us today. Dr. Ahmad is a distinguished researcher from the University of Florida. His work in self assessment has been instrumental in revolutionizing how we understand and enhance learning experience. Academic journey in PhD level began at the Florida State University. Now, at the University of Florida as an assistant professor, Dr. Ahmed continues to push boundaries in educational technology, combining cutting edge research with practical application that directly impact teaching and learning. His research interest includes integrating digital technologies, developing data driven instructional strategies, and creating systems that both assess and enhance students' learning. His contributions have been widely recognized with a publication in leading journals and presentation at prestigious conferences. For those who less familiar with the concept, actually self-assessment is a methodology that embeds assessment seamlessly into learning activities through digital platforms or games or sometimes educational videos. This approach evaluates learners in real time, re- reducing their stress of traditional assessment while providing teachers with authentic insights into students' progress. In technology-rich environment, it leverage tools like learning analytics and AI to offer personalized feedback, empowering learners and educators. I don't know, is that correct, Dr. Ahmad? This is or based on my uh, reading. Today, Dr. Ahmad will share his insights into what is self assessment and how it can be effectively implemented, and hopefully, we have time to discuss its applications or implications. This seminar actually is an invaluable opportunity for us at SQU to explore the opportunities like this approach presents. Whether you are an educator, researcher, or even as a pre service teacher, the ideas shared today hopefully resonate with your work and inspire your the new possibilities for the research. Without further ado, please join me in giving Dr. Ahmad a warm virtual welcome to join us. Dr. Ahmad, the floor is yours. Thank you.
Thank you so much. That was a great introduction. I've never had such an introduction before, and I think you did most of my work. I don't have to explain more. Like you explained everything, which is very
Great
nice.
research. Thank you.
Thank you for doing that. Bismillah ar-Rahman ar-Rahim. Thank you so much for having me. Assalamu alaikum, everyone. Hope you're having a good time wherever you are. But I think most of you are from Oman and Sultan Qaboos University. My name is Sayyid Ahmad Rahimi. I'm an assistant professor of educational technology here in the University of Florida. And I'm the director of the Class Lab, which stands for Creative Learning through AI and Self-Assessment in STEM. My students and I are really proud of this logo, and I always spend some time explaining it. So the A and I, which is AI in the center, look like a human. And that's how we approach using AI in education, which is human-centered AI. And I hope that kind of gives away what we are actually focusing on. So today I want to talk about self-assessment, a method that my PhD advisor, Dr. Valerie Shute, coined the term for and wrote a lot about in the past a decade or so. And now that she's retired, I'm trying to expand this method, optimize it, write about it, and apply it in different scenarios. But before I start, I think it's good to start from this classical test theory that most of you know, and it's not that difficult to understand. We assess learners to see what they know or can do. And this formula shows that the X stands for an observation that we made, or maybe a test that we took or gave to the students. And the T is the true score of that student's ability or knowledge. If you want to describe T, it would be that if you conduct the test many, many, many times, that is the level of knowledge that that student shows. But the E, which is error, changes that observed score each time you take the test. Maybe the student is fatigued or not in a good mood or something like that. They make a mistake and that reduces their score, or that sometimes by chance they respond to a question correctly, they don't know the answer for that, and then again the observed score changes. What we do in educational assessment is to try our best to reduce or minimize that error, designing good assessments, items or questions that can get more closer to that T score are actually what psychometricians and assessment designers are always trying to do. It's not, I think, possible to remove the error altogether because the T or true score is really difficult to get at. There are many things that can affect it, as I explained. So what we're trying to do is to minimize that error. Another thing that I want to talk about as an introductory section to my talk is this structure of arguments in general. Like when you have something that you have seen, like the observe the score, or a type of evidence or data that you look at, you are making an inference or you're making a claim based on what you saw. And you say, I saw this evidence, and therefore the claim is this. I saw this performance from this student, therefore their knowledge of this topic is at a high level or at a low level. So your basis for that argument is the data that you have seen. But in order for this argumentation or this line to stand, you have to back it up by some warrant or some backing that can come from the literature or can come from experience. For example, you say that because this thing have shown to be connected to the other skill that we are trying to assess, this argument can stand. Unless there is an alternative explanation that will kind of weaken this connection. Again, that alternative explanation can be the error that I just talked about in the previous slide. We are trying to reduce that alternative explanation, try to strengthen the argument with that warrant and backing of that warrant. Here's an example. For example, you have a candidate that you want to hire, and they wrote a cover letter, and it's well written, and that's the observed data that you have. So you say that the job candidate can produce appropriate and relevant routine business correspondence. Why are you saying that? You just saw a cover letter. How can you say that they can do well in business correspondence? Because a cover letter is a type of business correspondence, and therefore this is a positive example of a type of needed work, unless the candidate have had help writing that cover letter. For example, the candidate used ChatGPT, for example. In that case, you can't be confident that that person can do similar stuff in the future. So if you look at this architecture and you're kind of like sure you have data to back the alternative explanation, the A, and that's really strong. For example, you really saw that student using ChatGPT to write the cover letter. In that case, you cannot say that they can do good in the future when it comes to business correspondence. So then you will not hire that person, for example, or you ask them to write another cover letter or another form of business correspondence. So another thing that we should really think about is the difference between formative assessment and summative assessment, or assessment for learning and assessment of learning. I think you all also have known these two concepts very well. One is kind of at the end of the process. The other one is as the learner is forming, as the learner is learning through the process of learning. And I think this example really is a nice one when you are kind of creating these dishes as the clay is really very it's not hard. It can be formed. You can change it to whatever shape you want. That is the formative assessment. And when it's gone into the fire and it's not hard now, if you want to make any changes there, that will break and it's not going to give you the results that you want. Or another analogy is when the cook tastes the soup, that is formative, and when the guest tastes the soup, that is summative. My research and self-assessment is mainly focused on formative assessment and tries to provide supports for the students during the learning process. There are some problems that a self-assessment is addressing. For example, this pattern that we all are familiar with, we teach, we stop to prepare for testing, we conduct testing, and then we stop to grade the tests. And this pattern again continues. Those stop moments that sometimes take a long time can be harvested for teaching and learning instead of testing. So self-assessment tries to embed the assessment into the digital learning environment and help teachers to understand what the students know or can do at any moment in time, and then use those stop moments for teaching and learning, which can be really valuable. There are different types of validity when it comes to assessments. One of them is called educational validity, ecological validity. And that is simply, the generalizability or real life situation to real life situations of that assessment, how close that assessment is to real life. I think you will agree with me that a multiple choice question is not that close to real life. People don't respond to multiple choice questions in their everyday life, but a task that they perform, even in a simulated environment, can be closer to that type of task that they perform in real life. Traditional tests have low ecological validity. As I said, the focus is on assessment of learning in traditional assessments, standardized assessments, and not on for learning assessment. And sometimes when we conduct summative assessments, what we collect or the assessment results will not be used by the students. They will just ignore it most of the time because it's at the end of the process and they're done. They will go to the next step. No or little success in assessing hard to measure constructs like 21st century skills, creativity, persistence, and all of those important, crucial, assessments. But in self-assessment, we have done a lot of, work that I will talk about today on assessing creativity. And finally, test anxiety. Like as soon as you say that I'm going to test, we are going to have a test, some students or most of the students will feel anxious about that. That type of anxiety can increase the the error that I was talking about at the beginning of the talk. But now, with advances in technologies, learning sciences, AI, psychometrics, we can have assessments that are ongoing, unobtrusive, for learning, and ecologically valid. The basis for a self-assessment mainly is on these two big theories. The first one, flow theory by Csikszentmihalyi, that states that if the skill level of a learner is matched with the difficulty of the task that they are dealing with, they will enter that state of flow, which is right here. And it's not a very straight line. It's kind of like a boundary that you go in and out of it, or you are kind of like moving towards the flow. And if the task is too easy and your skill is too high, the task becomes boring for you. But if the task is too difficult and your skill is too low, it becomes frustrating for you. So it's going to be better for learner to have the task match with their level of skill. This theory kind of dictates that we need to find that sweet spot for each student. And not all the students have the same level of skill, and not all the students should be dealing with the same difficulty of the task. Similarly, in the ZPD theory, zone of proximal development, the best instructions happen in that like central, not central, but the middle area where the student can do things with some guidance. On the outer side, the students cannot do things even you provide guidance for them. And on the inner side, they can do things unaided. Without any supports, they can do things. That means like they have mastered those concepts. So if you want them to perform well, you need to provide instruction. Or if you want them to learn well, to be excited or to be really paying attention to the instructions, the best instructions is between these two things. Again, ZPD or zone of proximal development of every student is different. We need to ongoingly assess their skills or abilities to be able to provide tailored and adaptive supports. Self-assessment has these four processes where the student plays with the learning environment. If it's a gameplay, they play a game. Their data is captured to the log file, and there is a system to identify and analyze those log data that we need for the assessment. And then a student model is created using some statistical modeling. I will talk about those in a minute. And then when we know that a student's ability is whatever it is, then that information is fed back to the learning environment, and the learning environment can be adaptive in various ways. You can provide different challenges, easier challenges, more difficult challenges, or you can provide learning supports for the students to enhance their learning. And the more this process goes on, the more accurate the assessment becomes. And then the learners can achieve their goals that are defined for them. We have done many designs of a self-assessment in the past: physics understanding, calculus, creativity, persistence, problem solving, system thinking, and so on. Today, I will focus on physics understanding and creativity in several projects. So that was the process of self-assessment when it was designed, when it's implemented. This is the framework that we use to design a self-assessment, and then make sure that this assessment is valid, is reliable, and is fair to the learners. It is called ECD, or Evidence-Centered Design Framework. This framework came from ETS, Educational Testing Service in the United States, by people like Bob Mislevy, Russell Almond, and others. And as I said, like, this encourages the test designers to think about designing a test from this framework perspective. Start by thinking about the competency of interest. On the left, you see that the competency model. There are 4 main models in this framework, 4 stages, if you will. The first stage is to think about the competency that you want to assess. What is it that you want to assess? This question is simple, but answering it is not that simple. You need to really do a good job, talking to the experts, subject matter experts, maybe read the literature on that concept or construct, find the sub-facets of the construct, think about the strength of the connections between those sub-facets. And also these stars that you see here show the claims. Do you remember in that argument architecture, I had D and then I had C at the top? That's a claim. So when you assess the learner and your assessment is done, you will make some claims about their level of performance in the future. Those stars are those claims. For example, if you're assessing creativity, somebody with high creativity, what can they do? You write statements like that. A highly creative person will be able to do this, to do that. When you start by thinking like this, when you start by thinking like, these are the things that the student can do, these are the type of questions they can answer, it gives you a sense that what you can design for your environment. For example, if you want to design a game to assess something, by saying that a person who is creative can come up with many ideas, maybe in your game, you want to create a task that needs idea generation or brainstorming. In that way, you can collect some data to make some inferences about their idea generation or fluency. So the competency model defines what is it that you want to assess. The evidence model kind of indicates what are the indicators, what are the observables. In the competency model, we call these circles and the stars unobservables, things that you cannot observe. But you can observe them through the observables, which means the actions, the things that the students do. They're all in the evidence model. And then the task model kind of shows, these are different tasks. You can think of those like circle or triangle or rectangle as different question items or different task types. And then you can create as many of those tasks as you want to put together all of those tasks and create your assessment. But those tasks should have features, things that students can do. Maybe interactivity is in there, like if the student can type in a text, if the student can grab and drop something somewhere, anything that they can do to provide evidence for you, to provide evidence for the evidence model, should be explained in the task model. Then you give the task model with different types to the programmer or the game designer, and they will create as many of those task types with different levels of difficulty. And then you assemble all of them in the assembly model. So you have different types, different instances of those types, and you put together all of those tasks. And now you can kind of say that I'm covering all the things that I need to assess that competency. I have enough opportunities for the learner to show evidence that they can do whatever it is that I'm trying to assess. So this is called evidence-centered design. And if this is followed, usually the assessments will be valid and reliable, but you still need to assess the validity and reliability of the assessment. There are three key elements for a self-assessment to be called a self-assessment. A, it should be in a digital environment, technology-rich environment. Something like ECD or other frameworks should be used to develop or design this self-assessment. And then there should be something after we know what the student's level of understanding is. The formative assessment and feedback is very important. And something I want to point out here, that we usually hear assessment and test or measurement and we equalize them. We think that they are the same thing, but it's not the case. Assessment is more general. It is more comprehensive. Test is just one data point that you can have for a person and make inferences about their knowledge or skills. Assessment can include observations, data from here and there, students' interaction with the stuff, learning analytics that you can collect from the learning environment. And then all of that can give you an assessment of a person's ability. So here's an example of a game that we developed in the past decade. My advisor started creating this game called Physics Playground, and now I'm conducting research with it. So you see that there are different playgrounds here and different level types. As you remember, task type, when I was talking about, this is the first type of task where the students interact with this learning environment or this game, draw those lines, and the lines become alive. They become like physics machine, kind of simple machines like lever, pendulum, springboard, and ramp. And they need to hit that balloon using the ball. So here, obviously, the learner needs to use the knowledge of physics. And you see that we have several of those types. And we have another type, which is called manipulation level, where the students cannot draw anything, but they can only adjust the sliders and then solve the level. And we also have several of these level types, level generated. And those sliders are like about gravity or mass of the ball or air resistance. So yeah, you see a lot of levels here. In this project, we first, as I mentioned, started by thinking about what is it that we want to assess. It was physics understanding. And then we kind of digged into the literature of this concept for the 7th and 8th graders in the United States, and you found these concepts and their sub-concepts. For example, force and motion included Newton's laws, and then energy included energy can transfer or energy can dissipate. And then we also included some connections between these concepts. For example, if you look at the properties of momentum and conservation of momentum, you see that line between the two, which shows that these two concepts usually are taught together. And that togetherness creates a correlation. That's why you have that line. When you have these connections like this, that it's not just from left to right, which is, we call these type of connections part of. Newton's laws are part of force and motion. Properties of momentum and conservation of momentum are part of linear momentum. But we have other types of connections, as I explained. For example, from force and motion, you have connections to these three. That helps you to gather indirect evidence, not just direct evidence. For example, if you have a level which is about properties of momentum, that level provides evidence for linear momentum, and that information also provides information for force and motion. So this is going to be more accurate than just having part of connections. Here's an example of a game level called Florida, and the data that we collect in this level are like what sliders the student is adjusting. Is it the right slider or is it the wrong slider? The level is solved or not, or the bounciness option is checked or not. Because this level is about Newton's third law, the student needs to click on the bounciness, otherwise they provide counter evidence that they know about Newton's third law. and then the number of slider adjustments, how accurate they were in their solution. Have they done this like many, many times until they solved it, or they tried it a couple of times and then solved the level? And as you see that this level provides evidence for two concepts, Newton's third law and energy can dissipate. But Newton's third law is the primary concept of this level, and energy can dissipate is the secondary. That means that the status of this level, solved or not, provides more evidence, heavier evidence, if you will, for the Newton's third law, and some evidence for energy can dissipate. In order to make all of this work, you need to do some work in terms of computer structure and architecture. And it's different from project to project. In this project, we had two different servers. One on the left hosted the game and the data related to the game, the data related to the users, all of the user IDs and passwords, different aspects or parts of the game were included in there. And on the right is the assessment server, and it only included the data that is a filtered data from the log files that we collect. We have a filter that kind of removes the parts that are not important. And then through two processes, evidence identification and evidence accumulation, as you can see here under assessment engine, we can identify the data that is important, score the data, and then accumulate it. By accumulation, I mean simply maybe sometimes tally the numbers, just sum the numbers up. Think about it this way, that you have a test, it has 10 questions, and the students responded to those 10 questions, correct or incorrect, and you just count the correct ones. The student got 8 out of 10. It's a very, very simple accumulation system here, but you can have more sophisticated accumulation methods. For example, you can use Bayesian network modeling and accumulation systems. As soon as you have the data from this assessment server, that can go back from this line down here through a post request to the game engine, and then the game engine can use that data for some actions in the game. For example, it can show a dashboard to the students to see their new data, or it can make the game adaptive and change the challenges. For example, this is a dashboard that we show to the students. They can see their mastery level on those concepts and also the overall physics understanding. Here, I want to just debunk a myth about stealth assessment. It's called stealth assessment because you don't see a question in front of you, because you're immersed in the learning environment and you're just doing what you're supposed to do. It doesn't mean that the students don't know they are being assessed. It means that they are not kind of paying attention to that. They're just doing their work. They're just learning. We published the results of that study in this paper. If you are interested, you can scan that QR code and read the paper in full. The other study is about, I want to be faster. I think we don't have a lot of time, so I can have some room for Q&A. This is about creativity assessment. Creativity in the literature can be defined in many ways. One of them is through divergent thinking. And divergent thinking has 4 subfacets: fluency, flexibility, originality, and elaboration. We did not include elaboration in this case because you are not able to identify really good evidence for that. But fluency means like the number of ideas that you can come up with, or the number of solutions that you can come up with for a game level in Physics Playground. And flexibility is like how different those ideas are from each other. Are you fixated on one type of solutions, or you can provide many types of solutions? And originality is like how different or rare is your solution or idea from other typical ideas. Here, the green ones are indicators that we found in the game Physics Playground for each of those subfacets. For example, if you look at the first indicator for originality, it's about the difference between the ball trajectory in a solution from the expected trajectory. So we had like many solutions by different students, And when we looked at each ball's trajectory, it gave us a similar path, that's the expected trajectory. But if a student solved a level that ball traveled through a different trajectory, that shows that they came up with a different solution. Here is an example. On the top left, that's the level. The ball drops down from the sky and then goes out of the screen, comes back up again, until the student draws a line like what you see in the center and directs the ball to the balloon. That is a low original solution because most of the students have done that. But on the right, the highly original solution is what you're seeing there, that the student draws that machine, if you will. There's a weight at the end, and that that part at the top captures the ball and pulls the ball towards the balloon. And you see the trajectory of the ball is totally different from the one which is expected. And that is scored as highly original. At the bottom, you see another level, and it's getting at the appropriateness of the solution, because creativity is both about novelty, originality, and appropriateness or functionality. In the center, you see that the student is drawing a typical expected solution, a lever, and it solves the solution. It's appropriate. But on the right, the person is kind of like gaming the system. They are drawing those lines one on top of the other to elevate the ball to the balloon, which is kind of cheating, and it's not appropriate. And these type of solutions are not scored for creativity. Another space in a physics playground is where students can design their own game levels. There's an empty canvas for them. They can just drag the ball and the balloon, put the ball and the balloon anywhere on the screen, and design a level themselves. In this case, they're not solving the levels. They are designing the levels for others to play. And here they can show their creativity a lot. The two examples at the top are highly creative. The two at the bottom are not that creative. When we gather all of the data or indicators from the game, as I mentioned before, we can simply add the evidence up, sum them up, or you can use a sophisticated, simple, system of modeling, which is this one, for example, Bayesian network modeling. As you can see here, this is the competency model that I showed you earlier. Creativity has fluency, flexibility, and originality. And down here are the observed data, scored data. For example, the deviation from expected trajectory that I was talking about for originality is 100 here. That means that the solution that the system saw was rare and original. And that 100 provides evidence for this originality. You see that originality is now high, 80%. And then that propagates through the model and increases the overall creativity as well. A good thing about Bayesian networks is that you have a distribution of probability instead of one score. Here at the top, you see the creativity is 75% high for this learner, 22.8% medium, and 2.27% low. So it's kind of like giving you a sense that it's not, it's highly probable that this student is high on creativity, but there are some chances that maybe the student is low, medium on creativity. This is a better way of showing the level of skill of people rather than just one score. The results of this study is published in this paper. You can read this in full if you want. And right after this paper was out, we were reached by the Forbes magazine, one of the most very famous magazines in the world, about this study and how we managed to assess creativity, which shows that how creativity is really important, and the press is really paying attention to this stuff. We have done some review in the past, and we conducted, I think Dr. Khulabande also was involved in this systematic review, that we showed that these are the different competencies that have been assessed in the past decade or so after this concept was out, introduced by my advisor, and from different fields of study, education, technology, computer science, health, psychometrics, and others on different levels of education, adult education, all the way to K through 12 education. Another example, very quickly. So far, you saw a game being used in a self-assessment, but it's not just about games. It also is about other learning environments. This is a programming learning environment called EarSketch, which was designed by my colleagues at the Georgia Tech University and University of Florida. It was funded by NSF, National Science Foundation of the United States, and Amazon bought it. Now it has 2.5, maybe around 3 million users. And students write code, JavaScript or Python, and they put together pieces of music to create music. And this is a screenshot of this environment. As you see at the top, those are the music levels or music pieces of music. And then at the bottom, they write code. They have an AI companion with them that helps them create their projects. And I saw this opportunity here to create a self-assessment of creativity because I could see the evidence for creativity both in the code that students wrote and in their projects. So similarly, like other projects, I started by creating this competency model. The white part is the competency model, which is similar to what I showed you in Physics Playground project. Divergent thinking and complexity of the project are defined there. And the gray parts are the indicators or the variables that we collected from students' projects. For example, how many sounds did they use for fluency? And number of genres. Did they have just one genre in their music, or they combined different genres for flexibility? And for music complexity, we had entropy or rhythmic complexity and beat complexity. If the beat complexity and rhythmic complexity are less predictable, then the creativity increases. If they are more predictable, then the creativity decreases. Here is an example of the beat complexity and rhythmic complexity. For example, you have this music, has different layers on top of each other. For our uncertainty, we go from left to right and then average from top to bottom to see each layer, if each layer gives you more uncertainty or less uncertainty. And then you can have an average score for uncertainty or beat complexity. Here also for cohesion, we want to see if the sounds are complementary to each other or not. If they're not complementary, then it gives you a higher score, and then you average those higher scores from left to right. So you come from top to bottom, and then left to right, you average all of those scores. And you can have data for that. For the code complexity, where the students write their code, if a good programmer writes a code which is like few lines of code that can perform something really complex, that takes some creativity or knowledge of coding. As you see, the one at the bottom has more complex. That means more, they used functions more or conditions more, and they wrote something that can be done by many more lines of code. The one at the top left has low depth score, and you see that they just wrote line by line instead of using a loop or other conditions. So as I said, this type of code complexity, the one at the bottom, 1.73, needs more creativity, and we found some relationship between creativity and writing this type of code in this project. Oh, I have this in Farsi, but it's fine, I can explain. So we had some of it, I think you can explain, understand. We wanted to see if this assessment was valid. That means like if what we collected from the project is actually related to the experts saw. So we had 10 experts who knew this environment well. These people were people who have spent 5 years, for example, working with this EarSketch project, working with many students. They knew what can be done with this environment. And then we gave them 53 projects. That means like only the music of those projects, which is most of them were under 1 minute. Each person will listen to that music and score it from 1 to 6. 1, not creative at all, and 6, very creative. And then we averaged their scores, and then we correlated that with what we accumulated and gathered from the learning environment, and saw how is the correlation between these two data points. The instruction that we provided for the experts was this. And to just give you the gist of this, we just told them that we do not define creativity for you. Based on what you understand what creativity is in this environment, rate these projects. Also, don't expect to have a kind of a very high level of creativity, like a radio level creativity in these projects. Just compare what you hear to the previous projects in this space. This is the result, and the most important part of the result is this for me. Looking at the automated assessment or stealth assessment of creativity, the data coming from Earsketch, comparing to the external or expert assessment. It's a 0.5 correlation, which is really good, showing that we are going to the right direction. Another aspect was the background data that we had from these students: age, music making enjoyment, coding learning confidence. None of them correlated with creativity. That shows that they didn't have to do with students being creative or not, which is a good finding, because we didn't want this environment to for the students, if they want to be creative, they need to have all of those backgrounds. This shows that without those, they could also be creative. This study is published. It is not in press anymore. It's 2024. It's published in PACA, one of the respected journals in creativity, psychology of artistic creativity and arts. And that was it for me. I think we have some time for Q&A. Thank you.
Thank you very much, Dr. Ahmad. It was grateful, and thank you for your kind presentation. So if there are any questions, I would like to ask our audience to have any question. If not, I will start. Dr. Shobesh.
Assalamu alaikum. Thank you, Dr. Ruhollah, and thank you, Dr. Sayyid Ahmed. Thank you very much for the presentation. I just want to say sorry for being late. Actually, I wasn't online with the WhatsApp. I just want to, I'm a little bit interested in the paper about the first paper that you showed. So I think you was talking about some kind of two servers and one database. One database for the user accounts, and the other database was to save the assessment, I think.
Yes.
So all these parts are, explained in that paper. If yes, please I just want to take a photo, because I'm a little bit interested. This paper.
There is another paper that I can share with you, that we talk a little bit more about the computer architecture of this system. I can share with you about that. Architecture. Yeah, this is another chapter. And I'm putting that in the chat so if everyone can take a look at. But in this paper that I'm just sharing, the architecture is more explained in detail. The paper that I put the QR code here at the end, it is not that detailed in terms of the technicality of the stealth assessment. It's more about like what we did and the process that we collected data and things like that. But you can find more information in the one that is in the chat.
Thank you very much, Doctor.
Sure.
I also have one question. Dr. Ahmad, you have mentioned that we require some data which is they can combine or comes in from log files. Is it
Yes.
possible we collect the data from other learning environments such as LMS, for example, Moodle or any other LMS? I want to know, can we implement this technique through the data that we collect from other LMSs? I mean, LMS data.
Yeah, it depends on what you want to assess, and also the method that you are trying to, like the tasks that you're trying to embed in that LMS. Data, one thing that has been kind of like a movement recently, a field of study, if you will, has started, and it's called learning engineering. If you have heard about it, I think you know that learning engineering usually thinks about learning in higher education, using LMSs, using other learning environments. My area of expertise is more about K-12 education, but learning engineering usually is about these large scale, university level learning environments like LMSs that you mentioned. And one thing that they are talking about is that when the learner goes from one learning environment to another learning environment, the second learning environment should know what the student did in the first learning environment. Kind of like these environments are connected to each other and they share data among each other. They use something called XAPI, or Experience Data or Experience API. That is a our IEEE standard of data sharing. And if the LMS is using something like that, XAPI, they can, you can write a code to extract data from LMS. But you will not have the type of rich data that I was showing here about, for example, the game levels that the students played or their projects or things like that, if you don't write a code for it, if you don't embed the assessment in that learning environment. Usually the learning environments like in Moodle or other learning LMSs, they have some typical standard data. For example, where the student clicked at, or what learning support they saw, or what file they watched, or what video they watched. But if you, for example, come up with a task that the students, I'm just giving you an example, drag and drop kind of a test. You have a drag and drop test. If the data that you collect from that drag and drop is just the final state, correct, incorrect, you have that level of data. You don't have more than that. But if you also collect data on what element they dragged and where did they drop that element, how many times they did that, that is a richer data. If you have that, then you can identify that data, score that data, and accumulate that data. The difference between a stealth assessment, the way we do it, and what I just described, is that it is not stealth anymore, I think, because the students again see a problem in front of them. They see a question in front of them. Stealth assessment is like, you're working on this project, like the music project. It's not a problem. It's not it is a problem in some sense, but it's not a question. It's not a multiple choice question or drag and drop question. The more you go towards like the tasks or project-based learning type of learning environments, the more you make it a stealth. But it doesn't mean that all the assessments should be a stealth. It can be typical assessments. The point is that what type of data you are collecting, and if the learning management system allows you to do that. If it doesn't allow you to collect that data, you should have the technical capability, having the people who can write code for you, computer scientists who create a learning management system that can embed the data that you want into the learning management system and allow you to gather the data in real time. If these possibilities are not in place, it is not possible to collect the data that you're looking for.
Answer my second question then. Very good. Thank you very much. Any more questions, please? there any?
There are some in the chat, Dr. Rahman.
Oh, Prof. Van also asked the question. Dr. Ahmed, can you see the chat?
Yes.
Yes.
The instructor has to determine the rubrics and values to be added into the algorithm, like how to decide that it is right. It is high. I mean, the instructor can come up, but when you think about self-assessment, these methods are like a team-based project. Like you have many people working on the project: learning scientists, psychometricians, subject matter experts, computer scientists, and so on. So yeah, as a team, you need to come up with the rubric and then come up with the rules that how you can score that for high, medium, or low. And then that can be programmed in the game. Very simple. Like you can program a rubric into the learning environment. If the observed score was this, then it's low. If it was this, it's medium. If it was this, it's high. Exactly. Like in collaboration with the subject matter expert and the assessment designer, you can come up with a good rubric and then validate that and see if it's finally leading to the correct assessment. In order to validate self-assessment, one thing that I probably didn't mention, you always need to have, in the creativity example for EraSketch, you saw that we should always have something called like ground truth or external assessment. In the creativity assessment, I showed you that we had experts' opinion. That's something that we compared the in-game or in-learning environment assessment with the external measure. In the physics playground example, we had test of physics from students before and after playing the game. Then we correlated that with the in-game measures. And that showed us that we are kind of assessing a similar thing. It doesn't have to be really high correlation because we're not replicating those tests. It has to be in the same direction and meaningful. Yeah, the team is very important. Again, coming from the learning engineering movement, they say that the future of education is in it. It stands for IIT. The first I is instrumentation, which is similar to what I explained. Instrumentation means like you have this learning environment, you have to kind of do the instrumentation, which means data collection, which means gathering the data that can give you evidence for students' knowledge and skills. The other I is iteration, which means like you're not going to get it right the first try. It should be iterative, it should be ongoing. It's not that you're going to design a learning environment and done with it. You should design it and you should gather data all the time to improve that learning environment or learning management system. And finally, the T is team. These projects cannot be done by just one person or two people. It's a team of experts from different disciplines. But an interesting thing about team here is that everybody has a shared understanding about the project. If it's a data scientist, they understand what the learning scientist is saying. If it's a computer scientist, they understand what other people are saying. Each of them have their expertise, but they understand the whole idea of the project.
All right. Thank you very much. Yes, Dr. Muhammad, please.
Assalamu alaikum wa rahmatullahi wa barakatuh. I don't have questions, but I want to thank Prof. Ahmed Said about good presentation. Thank you very much, Dr. Ahmed. I am nice to see you.
You're
and
welcome.
Nice to hear your presentations. And I wanted to thank my colleague, Dr. Ruhallah, about his invitation for you, Yani, to present a good presentation for us. Thank you very much.
Absolutely.
Thank you very much.
My pleasure.
And welcome in Sultan Qaboos University. Thank you very much.
Thank you so much for your hospitality and for your kindness. Thanks, Dr. Ruhallah, for inviting me, and thank you everyone for listening in.
Sorry, Dr. Ruhollah, there is a question from Ms. Safiya Al-Sadi, I think.
Where is okay?
Is there any specific process for providing feedback? Yeah, we in the physics playground game we had an algorithm that for each so each playground included 10 game levels, and if the student was low on the concept of that game level, for example Newton's first law, the system shows that that student is low on that concept. The next level that they started was with a learning support. A learning support which was just a 1-minute video explaining that concept, Newton's first law, in the look and feel of the game itself. Like we had just videos that pop up and students watched the video, then started playing the game. Those who were high on that concept were just playing and without any learning supports. That was the minimal system that we included in the game. But there are many other ways you can think of.
All right. It seems we come to the conclusion of today's class.
Sure. Thank you so much.
I would like to take this opportunity once again to express my deepest gratitude to all of you for your kind participation and engagement. A special thank goes to Dr. Ahmed. Thank you very much for your sharing your invaluable expertise on stealth assessment, a topic that personally I'm interested in. Your work actually continues to inspire me, and of course I'm sure all of us here we are deeply grateful for your practical strategies and innovative ideas that share today with us. Thank you very much for your kind participation.
Thank you so much for having me.
Thank you very much, Dr. Ahmed. Learned a lot of new things today. Thank you.
Absolutely, that's very good message from you. Thank you.
I hope we have you here personally, physically, to teach us the practical way how we assess our students still.
Yeah, I think 1 hour is not enough to go deep into this. I have a course on stealth assessment. I designed a course on this, and it's like one whole semester just to design a stealth assessment, not even implementation, just designing. It takes one whole semester.
Good to inshallah. We will
have
try
a good day.
You to have a very good workshop with us, inshallah. Thank you very much. I'm going to
close.
Thank you again, and see you. Thank you again.
Assalamu alaikum. Thank you very much.
Assalamu alaikum. Bye-bye.